Okay, so now let's do some examples of some application. And so let's start with this one. It says, if a patient takes 60 milligrams of a medication 3 times a day, so 60 milligrams okay, 3 times per day. It says, how many grams will the patient take in 4 days? Okay, great. So how much milligrams will it take in 4 days? Well, how do we handle this? Well, we start with the fact that that this patient takes 60 milligrams 3 times per day. Okay, so we start with 60 milligrams. And what are we going to do? We're going to take another one that says per day, right? So we want milligrams per day. So we say, how many times per day do they take it? Well, it's going to be 3 times per day. And so what do we get? When we multiply this, we get 60, right? 60 times 3 per day. So we get milligrams per day. But we want to know how many milligrams for the 4 days, right? So how many days are we looking at? 4 days. 4 days over 1, right? We just want 4 days. So now days cancels with days. And so what do we get? We get 60 milligrams times 3 times 4. And what do we end up with? We end up with a total number of milligrams. So the answer is going to be 60 times 3 times 4. And so how many milligrams of the medication will the patient take? 720 milligrams. Total. Okay, here's another one. In this example, it says the length of a steel component is given as 8.6 centimeters. Okay. So we have a length that's given as 8.6 centimeters, right? And it's the length of a steel component. It says, what is the greatest possible error of this measurement in millimeters? Okay, so now, think about this. How do we find the greatest possible measurement? Or excuse me, error. How do we find the greatest possible error? Remember, it's half of the precision. Half of the precision, which means what's the precision of this measurement? It's to 1/10 of a centimeter. So that's going to be, so it's going to be half of that, right? So the precision is 1/10 of a centimeter, so it's 0.1. And we're going to take that and divide by 2, and this gives us the greatest possible error. So it's going to be 0.05 centimeters. But they want it in millimeters. So guess what? Now we're just going to convert it to millimeters. So there are how many millimeters for every centimeter? There's going to be 10. So there are 10 millimeters for every what? Centimeter. Right? And so centimeters cancel and we end up with what? 0.5 millimeters. And so that is the greatest possible error in millimeters for this measurement. Okay, let's do one more. So here, aviation. So it says the cruising speed of a Boeing 787. Okay, so we're looking at the cruising speed of a Boeing 787 is Mach 0.85. All right, Mach 0.85. Okay, now what does it mean? They tell us. So it means that 0.85 times the speed of sound. Okay, so they're not quite breaking the sound barrier. Okay? So Mach 0.85 means that you're going 0.85 times the speed of sound, which is approximately, I think, 220 miles per hour. But anyway, it says if the speed of sound is at cruising altitude is 295 meters per second. Okay, so at this cruising altitude, it's 200, what is it, 285? 285, oh, 295, so it's approximately 295 meters per second. Oh, maybe it's 220 feet per second I'm thinking of, but anyway, it's been a while. Where is it at? 295 meters per second. Okay, 295 meters per second. What is the cruising speed of the 787 in kilometers per hour? All right, okay, good. Okay, so we want kilometers per hour. So let's set this up. So again, we want it in kilometers per hour. So that's our goal. So we want to go from Mach 0.85 to kilometers per hour. So let's do that. So we start with Mach 0.85 over 1. Now we've got to convert from Mach, right? We got to go from Mach to kilometers. So, but we know that the speed of sound is at cruising altitude is about 295 meters per second. Okay, that's the speed of sound. Okay, so that means 295 let's see here. Oh, here. Okay, yeah, this will work. 200, now just bear with me. 295 what? Meters per second over what? 1 Mach, right? Because 1 Mach is 1 times the speed of sound. So if you're going 1 Mach, then you're going 295 meters per second. So then the Machs cancel. So it kind of looks weird. It's a little different than what we've been doing, but it's the way our process is still the same. So Machs cancel with Machs, right? So now what do we got? Now we're in meters per second. Okay. So now, if it makes you feel better, we could do this, right? Let's rewrite this and multiply across. And now what do we have? We got 0.85 times 295, and it's meters per second now. Okay. So again, if that makes you feel better, just write it like this. And we could start the next part of it. So we could start with 0.85 times 295 meters over second. And now we need to go to kilometers per hour now. So we're in seconds, right? So let's go to hours. Well, let's see, there's 60 seconds in 1 hour, or 1 minute rather. So seconds cancel with seconds. And then we're going to do another one because we need to go to hours. So we're going to say, okay, well then there's 60 minutes in 1 hour. So the minutes cancel. We're going to get hours in the denominator. That's what we want. So we're done with that. Now we need to go to kilometers. Well, then the last conversion is going to be what? It's going to be 1 kilometer is equal to 1,000 meters. So the meters cancels with the meters over here. And now we've got kilometers over hour, right? So we got kilometers over hour. And now all we have to do is multiply across the top and the bottom, and we're done. So our final answer is going to be 0.85 times 295 times 60 times 60 divided by 1,000, and it's going to be kilometers per hour. And so what's our final answer? Well, we put that in our calculator, and it comes out to 902.7. 902.7. Or approximately 903 kilometers per hour. And that's it. Have a great day.